I'm John Curran. I'm the president and CEO of ARIN, the American Registry for Internet Numbers. Let's see. You've heard of ARIN, though you may not know it as ARIN. If you've heard of WHOIS, when you're looking up an IP address, that's us. We're the WHOIS directory of all the IP numbers is administered by ARIN and four other regional registries. Collectively, we manage the database of all the IP addresses on the internet. I'm here to talk about IPv6 today, the new version of the Internet Protocol, and how it affects campus networks, because, quite frankly, this is happening. You don't even know it. Some of you might, but you probably don't. This is the biggest change we're ever doing in history of any system ever. It's being done on a global basis. It's on one of the most important things involved, the Internet, the infrastructure that lets everyone do all this amazing stuff. And no one's in charge. We have the world's largest technology upgrade project taking place on a worldwide distributed basis with no one in charge. So that's what I'm going to talk about today, because it does affect you. A little bit about my background. I've been involved in the internet since the late 80s. I worked for a company called Bolt, Beranek and Newman, BBN, in Cambridge, Mass, actually, not too far away from here. BBN was the contractor that built the ARPANET and MILNET, the first parts of the internet. BBN, I was the chief technology officer there. I ran BBN and ran its emerging internet company. It was one of the first 5 nationwide internet companies. Became part of GTE Internetworking, was eventually merged with Verizon, Bell Atlantic to become Verizon. I went on, I ran another nationwide ISP called XO Communications. And about 5 years ago, I took over running ARIN, the American Registry for Internet Numbers. ARIN is actually a trade association. We have 5,000 members in Canada, US, and about half of the Caribbean. Everybody who needs IP addresses to connect customers is a member of ARIN. You are not an ISP if you're not a member of ARIN, because you don't have any IP addresses to connect up new customers with. It's that simple. We're referred to informally as the IP Address Authority. I was the founder of ARIN back in 1997. Yep, a while ago. I was the chairman and on the board for 10 years. We lost our CEO. The board tapped me on the shoulder and said, guess what, you need to become the new CEO. So I've been actually off the board, but running it, or not on the board elected, but running it as the CEO, as an employee for the last 5 years. So let's talk about the changing IP campus networks. So you have campus networks, and they're going to have to change. The good news is only one small part has to change. There's a lot you can do, but you actually only need to change the public-facing portion of your campus network. Let's talk about why. Growth of the internet, 3 billion internet users. In 1995, 0.4% of the world had access to the internet. Today, 41%, 3 billion internet users. Anyone know how many people we have on the planet? Like, you kind of do the math. 3 billion, 41, divide, carry. About 7 billion, 7.5 billion, depending on who you ask. Okay. 7 billion people. We have 41% connected. We have a problem, though. Here's the problem. Those IP addresses, IP version 4, you know, the numbers, dotted quad, 192.7.12.11. There's only a 32-bit space in IP version 4. That's it. So the most devices we can connect to the internet with IP version 4, with the version that most of you are familiar with, is 32 bits worth of addresses. Anyone know what 2 to the 32nd power is, offhand? 2 to the 32nd power, 32 ones and zeros, how many possible combinations? Okay, so 4.3 billion. We have a possible set of 4.3 billion devices on the internet. Every unique device on the internet needs its own number. IP version 4, the number we're all using, the dotted decimal ones we're all familiar with, can only connect 4 billion devices. We have 3 billion internet users today. Okay, there's 7 billion people. If everyone wants to walk around with a smart device, that's 7 billion IP addresses. Oh wait, you actually want to have a home computer and a home connection. Well, that's another 7 billion IP addresses. Oh, you actually, in addition to mobile and home, you want something on your desk at work? That's another 7 billion. Okay, we've got 21 billion, and we haven't done any servers. We've only done what 7 billion people need at work, at home, and mobile. Okay? 4.3 billion devices can be connected with IPv4. We have 7 billion people. Those 7 billion people need 20 billion addresses on their own. Not to count everything in your campus network, everything in every enterprise network, everything in every cloud provider, everything in every search company. Every social media company, turns out they want addresses too for obvious reasons. Okay? IPv4, 4.3 billion possible combinations. 3 billion people. We probably need 50 billion IP addresses. There are people who tell me, but John, a lot of those addresses were given out long ago. They're not being used. We can get them back. Yes, we can try to slice and dice 4.3 billion to do a better job of serving 40 billion needs. Not going to work. Just doesn't work. Let's talk about this. So here's how we maintain the IP address directory. Every device connected to the internet needs a unique IP address. Everything. You send a packet out on the wire, it has an IP address. So we have to administer them. We administer them through 5 regional registries: ARIN 1997, RIPE for Europe in 1992, Asia Pacific NIC established in 1993, AFRINIC in 2005, and LACNIC for Latin America in 2002. The 5 of us run one directory and we give out IP addresses. APNIC and RIPE are out of addresses. RIPE ran out a year and a half ago, APNIC ran out 3 years ago. They're completely out of IP addresses. If you're an internet company in the Asia Pacific region and you have to connect up new customers, you have no new IP addresses to connect those customers' home connect devices or your business company's devices or those mobile users. You have no more IP addresses. So we put banners up on every building in the world that says the internet is full, go away. Okay? Because that's what it is. We're full. We're actually out of IP addresses. Does anyone know if we're full, or if we're out of IP addresses in the ARIN region? Anyone know? Okay, so you're at a momentous event, folks. We're very close. We are actually down right now to about 90,000 IP addresses left, which sounds like a lot. But we have basically been issuing them between 8 and 12 million per year. We're down to the last 90,000. Okay? We're basically going to run out in the next 2 weeks. And then in North America, we will be out of IP addresses as well. It's that simple. Now, this is a pretty dramatic issue. If you have no new IP addresses and you're a telecom company, you can't connect new customers. If you can't connect new customers, you can't grow your revenue. If you can't grow your revenue, your stock price won't go up. And investors will sell your shares and you'll go out of business. This is what we have to look forward to in the next 6 months, is that we are out of IP version 4 addresses. They've all been issued. Okay? It's that simple. So this is a pretty serious thing going on. How many people have heard of this before they came in? Raise your hand. Oh, see, I'm talking to the choir here. You guys all know about this. We're at the end of the world, and you've got a front row seat. That's awesome, okay? We're running out. It doesn't actually affect the connected internet, meaning if you're already connected with an IP address, you're already connected. You have IP version 4. Don't worry about it. A lot of people are connected to the internet. The thing is, that doesn't let the internet grow. It doesn't. So we can't just say the internet is closed. We need to actually switch to new internet protocol numbers. And we're doing that. We're doing it on a global basis right now. Everyone's doing it. We just didn't tell you. Okay? We're all doing this conversion, and we forgot to tell the 3 billion people already connected that we're upgrading the internet. Your ISPs have to use these new numbers. Okay, so what's happening? How many people have a smartphone? If you have a smartphone, hold it in the air. If you have an iPhone, lower your hand. We'll get to you guys later. All of you guys right now use IP version 6. You've already switched. You don't know it. Do you know why? AT&T, T-Mobile, Verizon Wireless have already switched to IP version 6. When they connect you to your cell tower, they don't give you an old IP version 4 address, those 32-bit addresses. They give you an IP version 6 address. Does anyone know how big IP version 6 is? It's not 32 bits, it's bigger. Anyone know offhand? 128 bits. We got a lot of bits. It gives you 128 bits. It gives you an address on the internet so big that we can't actually show it in numbers. We show it in hexadecimals. It looks like a MAC address. It's so big. It's this big, long alphanumeric thing. You don't see it. Why? Who looks at the IP address of their cell phone? What are you, nuts? As long as it connects, it connects. And it uses IP version 6 from your phone to the tower, from the tower to the internet. So AT&T has already switched. T-Mobile's already switched. Verizon Wireless has already switched. Verizon Wireless, 80% of their customers are using IPv6. They have no idea what's going on. None. Okay? IP version 6, 128-bit addresses. By the way, how many possible combinations of 128 bits are there? 2 to the 128th power. Come on. Easy. 5 trillion. Let's see. How about this? 340 undecillion. If you take 128 bits and you do ones and zeros, you come up with this weird word called undecillion. 340 undecillion. 340 followed by 36 zeros is how many combinations there are with IP version 6. Let's put it in real world. IP version 6 can number items. How many items can it number? 340 universes, where each universe has 1 trillion networks, and on each of those trillion networks, there's 1 trillion devices. Actually, I'm sorry, 340 trillion universes with 1 trillion networks on each, with 1 trillion devices on every network. That gives you an idea how many addresses. So we're going to go through this big change once. We're going from IP version 4, those little dotted decimal numbers you love, like 207.8.12.6. No one talks about them. We all talk about domain names. But we're going from IP version 4 to these big IPv6 addresses. We have to do it once. We will never do it again, because there's 340 undecillion IPv6 addresses. If we do it again, it's not my fault and I'll be dead, so I don't care. Okay? But we are running out of IP version 4. Vince Cerf, who, by the way, who knows Vince Cerf? Okay, Vince is my chairman. He's the chairman of the board of ARIN. He's on our board of trustees. He's my boss. Vint was involved. He's the co-founder of the internet. He's considered the father of the internet. He speaks about it. He was involved in designing the original IP packets. Vince says it's his fault, because he couldn't imagine us needing more than 32 bits to number every device on the internet. Well, right, maybe 30 years ago, that made a lot of sense. Now, 7 billion people, a smart device, a home connection, a work connection, that's 20 billion. And then all of the enterprise and all the search, it's easy to see why we need 40 or 50 billion. By the way, 40 and 50 billion is a low number. Why is it a low number? Because, well, in this building, right now, I don't see any IP addresses. I've walked into buildings where I can actually tell the fire alarms, the emergency lights, the lights above, the power outlets all have IP addresses assigned to them. There are new buildings coming out that have IP addresses on everything. You can walk into some places and they're using IP addresses for thermostats because they want every thermostat to have an IP address. So 40 billion is actually a low number. We actually probably need 100 billion. Your automobiles have IP addresses. Tesla, if you see a Tesla car go by, it has IP addresses assigned to it because it has electronics and networking involved. You're going to see a lot more. Every power meter being built today has an IP address assigned to it. Why? Because they want to be able to do smart energy. They want to be able to monitor things in real time so you can know how your power meter is doing. So we need the Internet of Things, it's called, and it's going to need a lot more addresses. All right, so what's happening? All the telecom companies are switching to IPv6. Where did IPv6 come from? In 1993, a group of us involved in the internet got together and we did an extrapolation of how long IPv4 addresses would run. And we realized we were going to run out sometime between 2010 and 2017. Wow. Now, by the way, in 1993, you know there was no web in 1993. In 1993, the internet was email and file transfer. It was email and FTP. Oh, there was remote login, Telnet, open, unsecure, remote login. There was no web. Tim Berners-Lee over in CERN hadn't yet done the HTTP protocol and the HTML markup. In 1993, the internet was growing so fast, it was growing 100% every 6 months, that we already knew we were running out of addresses before the web. Wow. Wow. Now we fixed that. We actually did some things to expand the rate that we were using addresses, and then the web came around and all of our gains in being more efficient with IP addresses were completely overtaken because this web was very popular. So in 1993 we knew we were running out. We developed the new bigger internet protocol. It's called IP version 6. We rolled out this new protocol. It's been in your laptop since 2001. It's been in your Cisco and Juniper routers since 2003. We actually have gotten this deployed globally in all the equipment, but not turned on. What's happened this year? All the major telcos have turned on IP version 6. They've turned on IP version 6, and they're using it to connect up new customers. Why? They have no choice. What does this mean to you? Your boss thinks that your website for your campus is on the internet. He spent good money to put all these systems on the internet. He believes you're on the internet. You're not. Surprise. You're on the old internet. You're on the old internet. When a new smartphone like yours, all of you who held your hands, and kept it up, when you go and connect to an IPv4 only website, what do you think happens? You don't have an IPv4 address. You have an IPv6 address in your smartphone. IPv6 packets and IPv4 packets, while we still run HTTP and SMTP mail and all the standard protocols, you can't just connect one to the other. They're incompatible. You have to translate. You folks have smartphones that can't connect to your own websites on your campus. Surprise. Now, obviously, no telco is going to roll out a smartphone and say, you can only get to the 5% of the internet that's on IP version 6. That's not what they do. They all put in gateways. They have huge gateways somewhere. So when your smartphone goes and accesses your corporate campus website, it goes to a gateway, and it becomes an IPv4 request to the campus gateway. And it comes back to the data center, and it gets mapped, and you get it back as an IPv4 request on IPv6 request on your phone. Your queries to your own websites are being mapped right now. What does this mean? Well, it has all sorts of very weird implications. Like, if you think you have a direct connection to your customers, most of them you don't, because 80% of T-Mobile is on IPv6. You actually don't have a connection to those phones. You have a connection to T-Mobile's data center. Congratulations. But if you want a faster connection, your website needs to be sitting on IPv6. How many people have a campus website on IPv6 right now? Raise your hand. Congratulations. You folks can leave if you want, or you can listen to me ramble, whatever you want. It's not going to change for the next 22 minutes. But that's what I'm basically going to cover. The problem is, if you don't have your website connected on IPv6, you're actually not getting direct customer connections, okay? Now, your IT department, that's you, or your hosting provider, if you've outsourced it, may already be working on this. It's not very hard. You do not need new web servers. You do not need new firewalls. You do not need new load balancers. You do not need new security monitoring equipment. You do not need a new internet connection. You do need to turn on IPv6 on every one of those things. You need to make sure your ISP has IPv6 turned on. And he may grumble about that. And there may not be a lot of people who know what you're asking about the first 3 times you ask. You do need to turn it on in your security monitoring. Why? Well, if you're actually carrying traffic to and from the internet and you're not looking at it because it's not turned on, that would be bad. So you probably want to do some security monitoring as well. Your firewall obviously needs to be turned on with IPv6. Exciting fact, your firewall may be passing IPv6 traffic right now with complete transparency and no filtering rules if you haven't actually gone and checked it. So you probably want to check that anyway. Even if you're not enabling your website, go make sure your firewall is set appropriately. Okay, let's talk about this. So there's also better performance. Has anyone heard of a social network called Facebook? Facebook, you've heard of it? Yeah, campus. It's like the online, like you have the guide of all the people in the school, and they have a yearbook, and they put it online, Zuckerman guy. Okay, anyway. So anyway, this Facebook thing, they're on IPv6. They, of course, have their website reachable via 4 and 6. Why? Because they actually want to be on the full internet. They're an internet company. Google completely IPv6 enabled, both v4 and v6. Facebook completely enabled. Bing, actually Bing was turned on and turned off and turned on again. I think it might be on now. I can't remember. YouTube is completely enabled. A lot of sites have already done this upgrade. Facebook noticed something when they turned it on. Performance to an IPv6 customer is 20 to 40% faster. That's pretty scary. They realize that their website going to some of their customers is 40% faster over IPv6. Why? Oh, look, IPv6 is not any magic sauce. It's not any faster than IPv4. But if they go to serve that customer with IPv4, and it's a smartphone using IPv6, their query goes to the data center of the carrier, gets translated into IPv6, goes from there back to the actual customer. The customer sends its response, which goes back to the data center, gets mapped to IPv4, goes back to Facebook's website. That process takes a while. That, by the way, is what 20% of America right now is doing when they go to your website. They're going through some data center to get mapped. If you don't have IPv6 turned on, 20% of the queries to your website are right now being translated, and they're slower, Facebook says. So, look, what are you going to do? Life after IPv4 depletion. IPv4 depletion in this region, folks, the next 2 weeks. We're going to get there very quickly. So, you want to be on both v4 and v6. You want to access the entire internet. You want to be able to get the reach of customers who only have v6. Yes, someone who has v6 on their phone, they don't know it, and they'll get translated to v4, but that's slower. You want to get a better end-to-end experience. Your video and audio will stream faster. You'll actually get more accurate analytics. I have a customer who told me that they see that increasingly their users live in New York, Virginia, Chicago, and the Bay Area. I said, really? They said, yeah. Yeah, we see now, like, people are moving to those cities. It's a big thing. I said, really? Really, do you think that? They said, yeah. I said, do you happen to know that the mapping of v4 to v6 for 2 of the major carriers in the U.S. takes place in Ashburn, Virginia, in New York, in San Jose? And they're like, no. And I said, so what you're seeing is you're seeing these IPv4 addresses. And you're seeing these connections come from those cities because the actual customer somewhere in New England, and it's getting mapped to IPv4 because they're somewhere in New England with IPv6. And they're being sent to the Port Authority building in New York, where they're coming back on one IPv4 address. You don't know when you give analytics to someone where they're coming from. Why? Because you don't see the v6 connection. If you actually want accurate analytics, you actually have to be connected to both networks. Now, why are you worried about this? Well, I'll show you. I'm going to skip ahead. There you go. See that slide? If you go to Google and type Google IPv6, hit return, it'll bring you to a slide that shows how many of Google's queries access the internet via v6. As of 2 weeks ago, 21.5% of the queries for Google come over an IPv6 connection. A year ago, it was 8%. A year before that, it was 2%. Okay? This is 20, and it's going up at a remarkably stiff clip. These queries that come over IPv6 are the ones you have no analytics to, are the ones that have worse performance. And I'll tell you, if you take Google as a statistical mean, 20% of the people accessing your website right now are using IPv6, and you have no idea about it. So, what do you have to do? Real quick, get your IPv6 address space. You talk to your ISP. You say, I want an IPv6 connection, and I want an IPv6 address block. Your ISP may not give you an address block. He may say, come to Aaron, come to us. If you've already got an address block from us, you get an IPv6 one for free. There's no charge. If you don't have an address block, we're going to charge you $500, $1,000, or $2,000, or $4,000, depending on how much you get. We'll charge you something per year. We're a not-for-profit trade association to run the registry. We need to keep the databases running, so we do charge. But if you already have a v4 address, there's no charge, so don't worry about it. Turn on your operating system, software, and network management terms for your public-facing servers. This is for your public websites. You do not need to change IPv6 in your campus local area network. You do not need to go to every department and change all of their servers. Not talking about that. Please don't say I said that here, okay? When you say I said that here, I get calls from provosts and CIOs who yell at me for what I said, okay? Your public-facing website. This is not hard, folks, okay? You know where it is. Take your email address, drop off the @ sign, put www in front of it, hit return. That's what I'm talking about, okay? Upgrade your router, firewall, and other hardware that serves the public-facing website. Get your staff trained, enable IPv6 on your website. Enable IPv6 on your website could be 5 minutes, literally. In Apache or IIS, turn it on, set the interface up and running, up we go. Could be a couple of weeks, could be a couple of months. See, it all depends on who wrote your website. Some people do really nifty things, like they get the IP address of the person connecting and they store it in a table somewhere. Well, yeah, when you go and get the string of the IP address connecting and it comes back at 128 bits or characters and you go and store it into that field and there's not enough room for it, or you do some things with logging, or you match IP addresses to see if this session was the other session, or your programmers have access lists so only certain IP addresses can do certain things, yeah, all that stuff breaks. And so that last step, don't be surprised that the people who actually configure and administer your website look at you and scream. Because if they've been doing something fast and loose with IP addresses, yeah, this is going to change the game. And it does. In general, 90% of the websites, not a problem. Just configure IPv6, it works. I have a personal website. I turned on IPv6. Took me 5 minutes. It was boom, done, up and running, wonderful. The next morning at 6 a.m., my website went away. Went and looked, my logging software runs at 6 a.m. Processes all the logs of everyone who queries the website. I took a field out of the log and stuffed it in someplace else, and you know, Perl exited right, and that was the end of my process, and I had no website running. So yeah, even I get bit by it. You need to actually talk to the people. They need to actually set it up in a lab, turn on IPv6, run it a while, make sure your logging, your querying, your auditing stuff all works. But it's not that hard. So why? The public's moving. You don't have a choice. We're not asking you whether you want to move to IPv6, okay? We're telling you the public internet wants to move. You can move your public-facing web servers to v6 or not. You don't have to. Your public website can be hosted somewhere else, and every time someone clicks next, it can send a fax to you as far as I'm concerned, okay? But the internet is moving to v6. If you want to be the technologist for your campus network, I think you'd want to know this. You don't have to do this. Your successor, when you're fired, can do this a few years from now. I don't care. The cost of IPv4 is, by the way, going to go up if you're an ISP. If you're an ISP trying to connect customers with IPv4 by getting new IPv4 addresses, this turns out to be an issue. And some campuses are large enough that they actually look like ISPs. If you think you're connecting a lot of new departments, colleges, affiliates, whatever, over the next few years, come and talk to me, because the moment you transition from an end on the internet to a service provider on the internet, this becomes pretty interesting. There's a lot of dynamics there. If you, this one, value in working with v6 sooner than later, the vast majority of America has no idea this is going on. That includes all of the enterprise community. I go and speak at various conferences. There's nothing like speaking at a Gartner Group conference or Interop and trying to explain this, and they look at you literally like you're crazy. That's okay. If you learn v6, in the next 2 years, there's going to be a shortage of people who understand IPv6 like you cannot believe. This is actually the Full Employment Act for Internet engineers and consultants. Learn this, and you have guaranteed career stability for the next 5 years, because this is where we're going. How often can I tell you about a field that no one knows about that I can absolutely assure you is going to take over the world? Here it is, okay? You have a son or daughter who wants to become an expert, literally point them at this, have them learn it, have them become an expert, they'll be employed for the next 20 years. It's that simple. Okay, you already saw this, 20%, 21. I'll actually bring that up just as we're walking up to see what it is today. I'll show you the curve. It's probably now 22%. That's how fast this curve is growing. Okay, get your v6 from us. Like I said, if your ISP won't give you an address block, come to us. We can give you one. But if you already have a v4 address, we can give you one for v6 of the corresponding size. Let's see. Talk to your ISP about v6. A lot of the ISPs, you're going to have to poke around and figure out to get the person who actually knows what you're talking about. Dual stack your network. For your public-facing infrastructure, you don't need separate routers, but you do need to run both IPv4 and IPv6. It's a parallel network. It has its own filter lists. It has its own IP addresses. It has its own packets. They run on the same wires, the same Wi-Fi, the same fiber, so they pass right by each other. You will have a campus network map, which is IPv4. You will have a second one, which is IPv6. You probably want to turn on IPv6 in your campus network someday, because the last thing you want is some department saying they need IPv6, them going to you and you saying we don't have it, and then them going to your boss and saying you're incompetent. So it might be good on your own service provider perspective to try to enable v6 across your network. But that's not what I'm here about. What I'm here about is making sure you get your website turned on. Make your mail, web, and applications turned on. Audit your equipment and software. When you go and connect your public-facing equipment to the internet with IPv6, you need to figure out everything it connects to, because it's not clear that everything you use on your website's necessarily v6 enabled, and you need to be very careful about that. You may have billing software, you may have external cloud providers, you need to know all the connections that that website makes. You need to talk to people about it, because some of them are v6 reachable and some may not be there yet. Encourage your vendors. There's a favor. It would be nice if when you buy equipment, you would ask the vendor to support IPv6. You don't have to, but it would be really nice. The vendors are just waking up to this, and some of them are having shock. What do you mean we're changing the internet? I didn't. Who decided that? No one did. The ISPs have no choice. They're switching to v6 because they want to stay in business. A lot of the vendors are, now the big router vendors, not a problem, firewall, security vendors, all of that. But if you're buying something on your campus, you're buying that new video projector, or you're buying your new personnel system that has an online timesheet, ask the vendor if he supports IPv6. Why? Because you want to make sure your vendors are aware of this. Again, at some point it might not be possible if you connect up someone with IPv4. So you want to make sure your vendors support v6 as well. Get IPv6 training for staff. We have some online. There's a lot of online courses that are very good. It's really not that different. Yeah, at the network level it's different, but HTTP, web, mail, all run over it just like anything else. Turn it on for your website. That actually, when you're ready to go, that means changing DNS to say this name for www.foo.edu is now reachable with an A record, an old IPv4 address, and what we call a quad A, an AAA record. You put an IPv6 address beside the quad A. When someone queries, if they see both a V4 and V6, they'll use V6 first. If you don't have v6 connectivity, they'll fall back to IPv4. You don't want to put your DNS and update it, your domain name, and put in a record for your website until you have v6 connectivity, because it means everyone has to time out once before they actually get to your website. Okay, check your equipment software, get educated, check your service providers, make an addressing plan, do some experiments. Do this in a lab first. Make sure your server actually works, then turn it on, then put it in DNS. Team Aaron, Get 6, who gets it? For more information, go to Aaron's website, click IPv6 info, you'll get it. The Internet Society is an association that helps coordinate Internet activities. They have information on their website, isoc.org. NANOG, North American Network Operators Group, is the group of the ISP engineers who get together, about 900 of them, 3 times a year to coordinate the Internet in North America. DREN, if you happen to be involved with the U.S. government, the Defense and Research Education Network has some great information involved. They have a nice white paper. Okay, questions. Got 6 minutes. Questions? Yes. So the question is, how do I know what my host numbers are in IPv6? Can I make them the same as they are in IPv4? You can, okay? You don't have to, though. Recognize that, much like when you connect to a Wi-Fi network and you get a dynamic address, IPv6 by default is going to use the MAC address, the actual Ethernet MAC address, and put the network prefix on and generate a dynamic address. A lot of organizations are like, okay, that's good enough for me. I know everyone's MAC address. I have to have that anyway for hardware inventory. I have to have that for security. I'm going to just start using MAC addresses. Some people actually have their devices announce their IPv6 address and make sure that it's not conflicted. So each device is hardwired configured with an IPv6 address. If you want to go do that on every device on your network, you can. But note, you're creating work by doing that. By default, you don't have to do anything. Everything will use its MAC address to build its IPv6 address. Right. Right. That requires each of your machines to hardwire its own IPv6 address rather than basing it off its MAC address. If the machines hardwire their addresses, then they can set it to any pattern you want, including one based on IPv4, and it makes it easier to put in DNS. Otherwise, when you're putting them in DNS, you literally have to go to the machine and ask, what IPv address did you end up with? That's what I'm putting in DNS. For public-facing servers, a lot of people do hardwire the address, okay, for the 5 or 6 machines, okay? By the way, some of them do it very interesting, like Facebook is FAC, the address is a hexadecimal address, so they can actually put FACEB00C, Facebook, okay, is what is in the public address for Facebook. Cisco's is dog food, which makes you wonder until you realize it's Cisco eating its own dog food, okay? So there are people who use vanity IPv6 addresses, but for public-facing servers, that might make sense. Internally, you probably wouldn't do that. Internally, people let them float dynamically. Okay, next question. I'm between you and coffee, and you want to get out there real quick. Is that what it is?
I got one.
Go ahead.
What happened to IPv5?
Ha-ha! You know, when you ask that question, there's a lot of people in this world who have absolutely no idea. Oh, by the way, this is how many addresses we have left down here. See, Aaron, IPv6 space available. This used to be whole integers, and now it's 0.00037 of one address block. With the address block 16 million, we're down to 0.3%, which means we effectively have 245 address blocks of /24, 245 address blocks of 256 addresses each. And this number's been going down pretty steadily, non-stop, and it's going to run out in the next 2 weeks. It really and truly, we're at the end here. Okay, Google, IPv6. So you asked what happened to IPv5, which is a great question. The numbers weren't assigned in order, first point. IPv1, 2, and 3 were lab experiments at the dawn of time. IPv4 is what we all used. BBN, my alma mater, the company I was the CTO in, we did an experimental protocol called IPv6 in the late 80s, early 90s, to do video over the network when no one was doing video. It was a failure, but we reserved the number. So when I was part of the task force that did, and I actually was part of the IPv6 task force that created the new protocol, when we got to the end, we had been calling it IPNG, IP Next Generation. When they actually went to assign the number, we all thought it was going to be 5. And they came back and said, oh, guess what? We've already assigned 5 in the directory. So it's IP version 6. So we had to skip from 4 to 6 because 5 was a 1990s protocol that had been assigned, and the IETF's practice, the Internet Engineering Task Force, IETF, the IETF's practice is we don't reuse numbers under any circumstance. So yeah, that's where it happened. It died in a lab experiment. Here is IPv6 adoption. That curve is really, you know, not too shabby. Yeah, excuse me while I make this. That's globally, we're up to about 8% globally. So 8% of the queries that Google receives from anywhere in the world, 8% of them are coming over IPv6. You go back to 2004, at the beginning of the year, it was 5.7%. Beginning of 2014, it was 2.7, so 2.7, 5, 8, you can see it's going up pretty impressively. You go to country adoption, US always leads. Well, today we're only still 21.4. I updated the chart last week, so it's not too impressive. But it is growing at a remarkable rate. And as you can see by that curve, this number, like I said, was 8% a year ago. So this is happening, particularly in North America, which is where your users are. I ask you all to pay attention, get your websites IPv6 enabled, talk to your vendors. Have a good conference. Thank you.